Hello, this is Mr. Wakefield here. We're now moving on into section 1.7. We're going to have a couple different parts to this. First part here on the first page is called Quadratic Inequalities. It comes from the fact that this is obviously a type of inequality. What is an inequality again? It's similar to an equation. You can see that this looks like an equation, but it has one of the inequality symbols. This one is greater than or equal to. This one is less than. Okay. When you have that little thing underneath the inequality symbol there, that is the equal to part. This one doesn't have that, so it just means less than, but this is greater than or equal to. So going back just to get you remembering again what inequality is all about a little bit. In the prerequisite review packet, towards the end of it, I have where we talk about linear inequalities. They are similar in many ways to quadratic inequalities, but there are certainly some differences as well. But the idea is that when you have a inequality and you solve it, okay, there's a lot more to it than just getting the variable by itself. Okay, you're gonna have a number line. It doesn't matter if it's a linear inequality like here, or if it's a quadratic inequality like here, or like in the next video where it'll be a rational inequality. They will all have this number line here. Okay, won't always look like this, but it'll be a number line. And then it will have this thing called interval notation. I'll go over that carefully, review that with you as well. All right. I'll continue to refer to this sheet here as we go along here because, like I said, there's a lot of similarities. Quadratic inequalities, they look a lot like quadratic equations. Okay. With quadratic equations, we now know what those are. Okay. The ones where we have the four different methods, okay, this one being the factoring method. We saw that in section 1.4. That's what this is. So they look just like that. The difference, of course, is that there's not a equal sign. There's an inequality. So here's the thing. When you do a quadratic inequality, they ask you to solve it. Yeah, you do first of all want to get the x by itself and all that kind of stuff. But what we're going to do, okay, and let me make it clear, all right, this is not a permanent change. This is just temporary here in the first step. Actually, it's in the first and second step. What we're going to do is we're going to change the inequality to an equal sign. Okay, you want to get it into this form here first, where you move all the terms to one side. Okay. And the reason why is because the factoring method is always going to work with the quadratic inequalities. As we know with quadratic equations, the factoring method sometimes works. Sometimes we need to use a different method. Sometimes we're asked to do a different method even. But here, the factoring method always works. So we always moved all the terms to one side, okay, so that there's a 0 on the other side. Won't always have all three of these terms. You can see here in this first example, we just have the x squared term and the x term. We don't have the term that doesn't have the variable in it. We don't have that one. That's okay. It's still quadratic because of the x squared. Okay, but we do need to get all those terms on one side. That's already done here, as you can see. The 0 is on one side. Okay, the x squared is positive, which we typically, even when that other term that I just mentioned was missing, you typically want to have that be positive as well, so that you can factor it like you normally would. And so I've got it all written like that already. Okay, whereas over here in this problem, I would need to move over the 5 here to get into that form, right? And I do that the same way I normally would when I do the factoring method with the quadratic equations, all right? I just, assuming there's no parentheses to clear out first, all right, you just add or subtract it over. And there you go. So first step is done here now. The first step was already done here. So now what we do is we change it to an equal sign. Okay, because we just want to know what's going to make it equal to 0 on the next step here. Okay, we'll do the same thing over here. Okay, eventually I'll stick to one problem here, but just want to show you how it starts out. So what you need to do here now that you've got it equal to 0, as it says here, it says now the real solution. So they want you to actually solve this equation now. And the real solutions, meaning the solutions that don't have that I in it, the imaginary numbers have the I in it, okay? You're not going to see that here, but if you were, then you'd have to get rid of those in this particular case. Because when you have those number lines that I was just showing you, these number lines, they don't have any I's on them, okay? But you're not going to see that anyway. You're not going to see any I's in these problems, in these quadratic inequalities anyway. So just solve it like you normally would, in other words, okay? Like I said, you could do the factoring method here. As you guys know, when you do the factoring method now, all right, we reviewed this already. We always, when we factor, we always look for the GCF first. Okay, there is a GCF here that's not equal to 1. Okay, it's equal to x. Factor that out, we get x minus 4 on the inside. Now, the x minus 4, as it turns out, is prime. Okay, because remember we said that when you have when you're factoring and you've got two terms inside of a bracket, you guys, okay. If the variable is to the first power, x to the first, that's automatically prime, okay, because it wouldn't fit into the two-term formula that we normally use, a squared minus b squared, okay. Since it's x to the first power, that's prime, due to the fact that it's x to the first, okay. So now I'm done with the factoring step, okay. Again, we're doing the factoring method for solving quadratic equations. So that means that we set each factor equal to 0 there. Okay, we have whenever you have a single term times a bracket, you set those two things equal to 0, just like I did. You then solve those equations. Okay. The x equal to 0 is already solved for because x is by itself. The x minus 4, I need to move over the 4. So we got two answers, 0 and 4. Now, again, what did we just solve here? We just solved the equation, not the inequality. Okay, solving the equation where you change it to an equal sign, that's just part of the problem, you guys. All right, we still got a couple more steps to do. Big steps, in fact. What you do after you solve that equation when you change it to an equal sign in the second step, okay, the second step that I mentioned up here, when you find those solutions here after changing it to an equal sign, they become what we call the boundary points. Let me show you what I mean by that. What you do is you write down a number line, you take those two answers, and make sure that the smaller number is always on the left side of the line, because that's how a number line works. You always go smaller numbers over here and bigger numbers on the right-hand side, okay? So you got 0 and 4. What that does is it breaks your inequality into three parts, your number line in particular. It breaks it up into three parts. Okay, and what you do is this. You go back to the original inequality. You do not do the equation. The equation should be completely out of your mind now. The purpose of the equation was just to get these answers right here, 0 and 4. Forget about the equation now. This is all out, should be out of your mind now. You should focus back on the original inequality. So once you get to the number line step, just focus on the inequality with the inequality symbol here. Forget about the ones with the equal signs in them. Okay? And so what we do is we pick any number we want that's inside of this first interval. Okay, this over here is negative infinity. It's a negative infinity because the arrow means it goes forever to the left, but going to the left is in the negative direction. Okay, because the negative numbers are over here and the positive numbers are over here on the number line. And so this is from negative infinity then, because an arrow means it's going forever, and so that's infinite. So negative infinity to 0. Pick any number you want between negative infinity and 0. I'll go ahead and pick negative 1. You can pick anything you want, though. Okay, just trying to pick something simple there. Go ahead and plug it into the inequality, not into the equation, like I said. Okay, and then just like we did when we were doing remember we were doing the radical equations, and you had to check your answer at the end of the problem, and you plug the number in to see if it was true or not. It's very similar to that. What you do is you figure out what each side is equal to and then see if it's true or not. But the difference this time is that we now have an inequality instead of an equal sign. Okay, so it just needs to be greater than or equal to instead of being equal like it had to here. Okay, but let's see what happens. So, but just like we did with the radical equations, you figure out what each side is equal to. Don't try to combine the two sides together in any kind of way. Just keep the two sides separate and figure out what they're equal to. And as we know, exponents come before multiplication, and then multiplication comes before subtraction. So we do the exponent first. Then, remember now, you guys, x squared minus 4x, that's a normal run-of-the-mill polynomial, okay? Where you got two terms separated by a minus sign. It could also be separated by plus, but I want to focus on the minus right now. If you've got two normal terms separated by a minus sign, okay, when you plug a number into that second term, you guys, remember again, and we saw this with the quadratic formula as well, when you plug that in, remember that's the same thing as 1 plus -4 times -1. Okay, let me remind you of what I meant by that with the quadratic formula. I'll show you that. Here it is. When we plugged in here, remember I said that b squared minus 4 times a times c, it's the same thing as b squared plus -4 times a times c. Okay, and the a, b, and c were plugged in. So same idea here, okay, where you've got the minus could be plus and then the -4 times these things. In the same way, this is x squared plus -4x. All right, when you have two terms separated by a minus sign, think of that as plus -4 times x. All right, and that's a good idea because when you do the multiplication, it allows you to do -4 times -1, okay, which a lot of people prefer to do. All right, so yeah, if you've got a term minus a term, sorry, that fell off the screen there. When you got a term minus a term, all right, think of it as plus -4 times that thing that you plugged in there, which is -1 right here. Okay, so what do we got here? We got 1 plus -4 times -1. -4 times -1 is positive 4, so it's going to be plus 4. Okay, but remember it's plus, so you got to bring that down. Okay, but the minus becomes a plus when you say plus -4 times -1. So then we then figure out 1 plus 4. Is this true or false, you guys? Is 5 truly greater than or equal to 0? Okay, when they say greater than or equal to 0, it just needs to be one or the other. Okay, is it greater than or is it equal to 0? If either one of those things is true, then this whole statement is true. 5 is indeed greater than 0, isn't it? It is a bigger number than 0, so it is true. What does this mean? Well, in terms of a number line, you guys, when you have greater than or equal to, I'm sorry, not what I meant to say was whenever you have true, whenever it's true, what you do is you shade it. You shade it in. If it had been false, I would not be doing this right now, and you'll see that coming up here on some of these. But it breaks this up into 3 total intervals here. Next, we're going to do 0 to 4, and then we'll do 4 to infinity. Okay, if it's false, don't shade that interval. If it's true, you do shade it. Pick a number between 0 and 4. I'll go ahead and pick, how about 2? Okay, we could do 1. That's fine as well. Anything between 0 and 4 is fine. All right. So I plug that in, and I get this right here. And once again, we do order of operations on each side of the inequality, keeping the two sides separate, and then we'll determine at the end, after we figure out what each side is equal to, whether or not it's true. So exponents first again. And then once again, we think of this as plus -4 times 2. So that's plus -4 times 2 is plus -8, isn't it? Okay, now when you have a number plus a negative number, you can still write that as -8. Okay, when you have plus like I said, when you have a number plus a number, you can change that to, if it's plus negative, you can change that to minus positive. Plus negative 8, as you guys know, is the same thing as minus 8. Okay, you could say plus negative 8 if you want. You'll get the same answer. All right, I'm just saying that you could do it either way. All right, so 4 minus 8 is what? Negative 4, right? Okay. And is that true or false? Well, as it turns out, negative 4 is less than 0, so it's not greater than or equal to 0, is it? So that's false. Since it's false, we don't shade it. If it's true, you shade it. If it's false, you leave it blank. Let's do one more here. How about I'll plug in 5. Anything between 4 and infinity is just fine. I'll use 5. Plugging that in. Remember, when you plug numbers into a variable, you always use a parenthesis that is initially empty, okay? Use a parenthesis that's initially empty to replace your variables, and then you put the number in there. Okay, very important to use those parentheses in order for it to come out correct. Now let's do it here. 25. Exponents first, right? Then we do the multiplication. Plus negative 4 times 5 is plus negative 20. But as we said, if you have a number plus negative 20, that's the same thing as the number minus 20. So we got 25 minus 20. 25 minus 20, we do subtraction last, and that is 5. And once again, we know that 5 is greater than 0, so that is true. So we're going to shade whatever's true, right, as we just talked about. Now, we're not done here, right? We've got a little bit more to do. Here's the thing about number lines, you guys. If you have a shading, you guys, that's on one side of a number, see how the shading is on one side of the 0 but not the other side? If you have a shading that's on one side of a number but not on the other side, you need to close up that shading. You can't just leave it hanging there like that. You need to close it up with either a round bracket or a square bracket. One of these two here. Which one do you do? Well, it depends on the problem. If you have a equal to underneath your inequality there, okay, in other words, if this had been greater than, it would be different. But since it's greater than or equal to, you use a square bracket. Always use a square bracket, okay, with the numbers, all right? I'm not talking about infinity and negative infinity, which I'll get into in a minute here, but just the numbers that are in the middle of the area of the number line, not on the ends here where it's negative infinity and positive infinity. No, in the middle, we use one of these two, but it depends on what this is. Okay, so if this had just been greater than only, you guys, but not greater than or equal to, then you'd use the round one. Okay, when it's got the equal to, you use the square one. There is one exception to that you'll see in the next video. Okay, I'll go over that very carefully. But otherwise, that's what you do. Okay. Same thing with the 4, right? The 4, you got to put a bracket there because the 4 is shaded on one side of the 4 but not on the other. Again, we use a square bracket for the same reason. It's because the inequality has the equal to thing underneath it. Now, the last thing we need to do, and the reason why we did the number line was so that we could figure this out right here. We need to do the interval notation. Let me show you how to do that. Once you know what your number line is, and you've got your shadings and you've got your brackets as well, what you do is you start out on the left side. You always got to start out on the left, okay, when you do the interval notation. And you only do what's shaded. Okay, so where does the shading start? Well, since it goes all the way to the left, that means it basically starts at negative infinity. Remember, the arrow means it's going forever to the left. That means negative infinity. So it starts at negative infinity then. And when you have a shading, okay, you put the beginning point of the shading down. You write that down. Then you put a comma. And then wherever the shading ends, that's the next thing that you write. So since it ends at 0, we write 0. Okay. Now we need to use the same bracket for 0 as we did in the number lines to keep that the same. You always use a you always use a round bracket for either negative infinity or infinity. Always do that. It does not matter, okay, whether that is got the equal to thing or not. Okay, the reason why is because a square bracket means that if you plug 0 into the inequality here, it would be true. If I plug 0 into the inequality right here, it would be true. It would be 0 greater than or equal to 0. That's what it would end up coming out to be. But because the equal to thing is in there, all right, this would be true, wouldn't it? Because 0 is equal to 0, and since it has that equal to thing in there, that counts, okay? 0 is indeed equal to 0, and so that's part of the statement here. It says it could either be greater than or it could be equal to. On the other hand, you don't have to write this down. This is a separate situation potentially. But see how this is not true. 0 is not greater than itself, is it? So that's why I'm saying, okay, if you did not have the equal to thing in here, all right, this would not be a square bracket. It'd be a round one. And it's all because when it's equal, it makes it true, okay, because the numbers are going to be the same right on the boundary numbers, 0 and 4, okay. But if you don't have the equal to, it's not going to be true. Okay, so I'm going to throw that out. I'm going to get rid of that there because I was just pretending like it was a different kind of problem where it didn't have the equal to. So yeah, so whenever you have the equal to, like I said, it's a square bracket because that's what makes it true, like you can see here. All right. But the thing is that infinity and negative infinity, they're never true. And the reason why they're never true is because infinity and negative infinity are not even numbers. They're not numbers. Okay? And a round bracket means that it's not true. A square bracket means it is true. And so if you plug in negative infinity and infinity, that really doesn't make sense because they're not even really numbers to begin with. They can't be solutions then. Okay? And so that's why we always use round brackets for negative infinity and infinity. So to review here, negative infinity and positive infinity always round. And then the rest of the numbers, okay, the ones that are in between negative infinity and infinity, like 0 and 4, it depends on what the inequality, whether or not it has the equal to thing in it or not. Now, let me finish this up here. We're not done yet. When you have a shading that stops, and there's a gap here where there's nothing here, it's empty, and then the shading starts back up again, here's what you do. You put a U here. U meaning union, meaning that we're going to unite the two sides here, the two shadings. And then it starts back up at 4. So wherever it starts back up, just like we do with negative infinity, where it starts, you put that down, followed by a comma, and then where does that piece of the shading end? It ends at infinity, right? Okay, remember infinity is always round. And 4 is square, just like it was in the number line, okay? It will stay the same. Okay, so whatever brackets you have in the number line, they will stay the same down here in the interval notation. And then like I said, the infinity and negative infinity, they will just be round when you do the interval notation. No brackets up here for infinity and negative infinity. You just have arrows, but you'll have round brackets down here all the time when you have infinity and negative infinity. Okay, so we'll go over that more, all right? More of that interval notation, bracket stuff as we go along here, all right, if you're still trying to get used to it. Okay, let's go ahead and solve this now. This one looks like the Berry method here, doesn't it? 3 times 5 is 15. What two numbers add up to 16 in the middle but equal 15 when you multiply them? That would be 15 and 1, wouldn't it? 15 plus 1 is 16, and 15 times 1 is 15. So we do that thing, the Berry method, where we, since this is 3x squared, we do 3x and 3x. Since we have positive 15 and positive 1, we're going to say plus 15 and plus 1. You still got to do that last step of the Berry method. That's that one where you factor out the GCF out of each bracket. If I factor out 3 out of this, I get x plus 5. The GCF here is 1, though, so if you factor out 1, it's not going to change it, so you can just skip that since it's not going to change it anyway. And those are the two brackets that you end up with. So we're done factoring here because these two brackets both have two terms, and they both have x to the first power. As we said earlier, that means that they are prime. Okay. Later on, we'll see a situation where, and maybe you've seen it in the past, where, and it's also in the prerequisite review packet briefly, if you want to look at it, but if you want to review that. But sometimes two brackets, one of the two brackets can actually factor down to two more brackets for a total of three brackets. Don't need to worry about that right now, but we will see that in the future. Yeah, you don't need to worry about that in this section, though. Set those equal to 0, just like I did over here. Okay. And we get what here? Subtract the 5 over to the other side. On this one, we need to subtract the 1 over to the other side and then divide out the 3. So what do we get? We get negative 5 and negative 1/3. So let me put those down. Negative 5, negative 1/3. Then we test each one of those three intervals the same way we did in the last problem. Okay. Plug it into, not into the equation, but you got to plug it into the inequality. First one, I need to pick a number between negative infinity and negative 5. I'll pick negative 6. You can pick negative 7 or negative 8 if you want, your choice. So I plug it into the original inequality up here. I'll get 3 times negative 6 squared plus 16 times negative 6 is less than negative 5. True or false? Okay. Again, we need to keep the two sides separate. Okay. And do order of operations on each side here. Okay. We do the exponent before the multiplication. Then we do the multiplication. And you can do both of the multiplications at once. Theoretically, you're supposed to do the one on the left first and then the one on the right, but it's going to come out the same. Okay, if I do 108 first and then I do this one, it's still going to come out this way. So as long as it comes out the same, you can do two steps in one right there. Just make sure it is indeed coming out the same as it would have if you had done the two steps separately, left one first and then the right one second on the multiplication. Then we do the subtraction to finish it off. And is this true or false, you guys? 12 is actually greater than negative 5, isn't it? It's not less than negative 5, so this is false. That means we don't shade it, right? Let's keep moving on here. Give me a number between negative 5 and negative 1/3. How about, say, negative 1? Okay. So I'll plug that in. Forgot to put the exponent there. There it is. And so we do the exponent before the multiplication, as you guys know. And then what? Then we need to do the multiplication. Like I said, in this case, you could do them both at the same time. Okay. 3 times 1, and then 16 times negative 1 is negative 16. But as we said, see, normally this would be 3 plus negative 16 because we have a plus there. All right. But like I said before, when you have a number plus negative 16, you can write that as minus 16 as well. 3 minus 16 is negative 13. That is a true statement, isn't it? Because negative 13 is even more negative than negative 5 is, and therefore it's less than. Okay. And so therefore it's true. True means we shade it, right? And finally, this last one here, any number between negative 1/3 and positive infinity way over here. How about 0? 0 is usually a good number to plug in, okay? An easy number to plug in if it happens to be something that you're allowed to plug in. And on this interval, 0 is one of the numbers you can plug in, okay? So 0 squared is 0. You might see what's going on here when you plug in 0. If you plug a 0 into a polynomial, a normal polynomial like 3x squared plus 16x, okay, it is going to be equal to 0 unless there's a term that doesn't have a variable in it. But if each term in the polynomial on that side of the inequality has an x in it, then when you plug in 0, it's going to make all the terms 0. And then what happens when you add, or even if this was subtraction, it wouldn't matter. When you add or subtract terms that are both equal to 0, you're just going to get 0, aren't you? Okay, so that's what happens here, all right? 3 times 0, 16 times 0, they're both equal to 0. And it's going to end up being equal to 0. 0 plus 0 is 0. All right. So we end up with what here? Is this true or false? Well, 0 is bigger or greater than any negative number. It's not less than. So that is false. And therefore we don't shade it. So we have now done all the shadings that we can. We've tested every interval. That's what you want to do. Okay, when you do the number line, test each interval, shade what's true. Don't shade what's false. Then you got to do that bracket thing. Okay, in other words, these two numbers here, -5 and -1/3, they are shaded on one side of the number but not the other side. Same thing here, shaded on one side but not the other. So you need a bracket to close that up. Which bracket are you going to use this time? Well, because of the fact that there is no equal to underneath this inequality symbol, we are going to use a round bracket on these two numbers here. Okay. Again, if there had been an equal to underneath that, it would be square on both of those numbers, just like it was here. Square bracket, square bracket. Okay, here it's round brackets. And so we've done the shadings. We've done the brackets. Now we're ready to do the interval notation. We're done with the number line when you're done with the shadings and the brackets. So, what do we got? Remember, with the shadings, you always have to start where the shading starts. So we start at -5, and then you put a comma, and then you look at where the shading ends. It ends at -1/3, right? Okay. Since both of these are round brackets, there'll be round brackets here as well. There's no infinity or negative infinity here, so you don't have to worry about that. Now notice there's not another shading after that. There's just one shading, so you don't need that U thing this time. The U thing is when you have a shading here, and then the shading stops, and then it starts back up again. That doesn't happen here, so you just need to write this. Okay? So that's quadratic inequalities. In our next video, we'll look at inequalities that have fractions in them, okay? But these are the quadratic inequalities. Let me know if you have any questions. Okay, you have a good day. Take care, and we'll see you back for that next video with the rational inequalities.